All right. How are you doing this morning, sir?
All right. I faced some dilemmas while working on the editor.
Sorry, say again.
I faced some dilemmas.
Oh, you did. Excellent.
Yeah.
Excellent.
so
Get into something interesting today. Yeah.
yeah. So I guess some of I think I encountered two main problems.
Mm-hmm.
So one is that like I guess I don't have a clear understanding of like what a good interface looks like. So I think it would be helpful if I had like maybe like a checklist or something like, oh, if I do XYZ things, all right, I know for sure that I did something correct. Um, yeah.
What you've just told me is if you just give me a checklist on how to say, write a good story, if I do X, Y, Z things and I know I have a good story, right? Like J.K. Rowling would love that.
Yeah.
Ah,
um, and then
yeah.
the second one was about the test, right? So we changed something to like one of the methods it was used to like just display the data, right? And then um what's it called? Our test that we're using to like check if it's like the expected result is like a string, right? And then um it's sort of like, so originally it was a string and we changed it to like an array, a U8 array, and like all the tests broke, which is like expected, right? But
Yeah.
like
Which test are you talking about, first of all?
it was let me find it. Um it was in insert glyphs. Most of it was what's it called? So most of the test uses like a method called like dot contents, and that like just prints out, or it doesn't print out, but it is the, or it what's it called, as it prints out like the position and stuff like that, or no, it
Okay.
prints out the data, right? But then in the trait we changed it to like a U8 array, and then but because the expected result is a string, the test breaks. So like it feels like the test is like super dependent on like whether the the expected result is a string, if you know what I
Right.
mean.
Yeah. Yep, it does. It does. It does feel that way because I think that's true.
Yeah, so I
Well,
guess the dilemma is that like the test is like super dependent on, I guess, the implementation. Um
yep.
and so like I guess the dilemma is like how do I get around that?
Perfect. Well, you know what? I'm gonna. Ooh, it seems like both of the questions, like how do I design an interface, and then how do I effectively loosely couple to that interface so that sort of changes that I might make to the interface are not unduly, don't break things
Yeah.
unnecessarily. Oh, that's hot. Okay, my tea. Okay, so I'm gonna maybe start with the second question first because I think it's a shorter answer.
Okay.
And what's the checklist that makes sure that I always make good interfaces? That's definitely a longer answer. But I can tell you this: if I can come up with an answer to that, I'm instantly retired. I can sell that. I can bottle that. So I'm hoping I come up with a really good answer. All
Because
right.
I'm just like typing, right? I'm like, is this
Yeah.
what I'm supposed to do? I don't know what I'm doing.
Yeah. Now there will be guidelines that we can talk about.
Okay.
How I sound like Pirates of the Caribbean. Uh, but yeah, there'll be guidelines that we can talk about. I think that will help you. Okay, so second question first. The expected result is definitely a string. The result contents are going to come back as some. Right now, they're a ref slice of U8. So the thing that you can do is you can take your string and then you can turn it into a slice of U8. Maybe I should share my screen.
Yeah. I was looking through my code right now.
Yeah, I was like, I can see my code. Share.
So is that what like I guess should be done? You just change the test itself.
Yeah, like so we have to figure out what we want this test to answer,
Okay.
right? Excuse me. We can say something to the effect of, I don't care what the contents are, as long as they, as long as we can iterate over them. But that's not what our interface has said, right? In our wishful driven design, res.contents returns a ref slice of U8. So we could have said something like impl iterator item equals, ref U8 or something like that, where it's now any type. It can be a vec, it can be a string, it can be a this, or it can be a that, as long as you can iterate and get ref U8s out of it. But the byte slice is such a common data type that it's sort of like what everything else decomposes into anyway.
Okay.
So while saying I'm just going to get an iterator of something, so I'm just going to get some type that implements iterator of ref U8 is the most general way of expressing a collection. This is the next most general way. And this has the advantage of guaranteeing some efficiencies, because as a slice, the U8s have to be contiguous in memory. And so as an iterator, they do not. So this is constraining the iterator a little bit, but it's done in a good way, and it's very, very, very common. So I would say this is an idiomatic signature to return, as opposed to before where we were returning a vec, I think, which is a vec of U8 would be less common. If you're giving back a vec of bytes and you want the person to be able to add to that vec of bytes, or add to that collection of bytes, then you'd return a vec of bytes. But that's an unusual circumstance. So the simplest answer, excuse me, I haven't yawned all morning, but as soon as we start talking, you see here that there's an as bytes?
Yeah.
That's on string.
Yep.
And so that method will return a ref U8 slice, a ref slice of U8. And so we can just do that, and then they will match up.
Okay. So like, let's say I decide to change it again, right? I just like change the way expected result is, or like I just change that type in the test.
Uh-huh.
Okay.
I mean, when you're writing the tests, you're going to want to compare against the type you're getting back from your interface. So as long as your interface is stable, you shouldn't have to change that too much. Remember, content is a public API. Excuse me. Wow. Because it is implementing a trait, that means that all of the functions within it are public. And so if you go in and you change your trait, you're going to break all the types that implement the trait. You're going to break all the types that talk to any other types that implement the trait. It's a widespread breakage because you're changing a public API.
Okay.
Does that make sense?
Yeah.
Right? If you go here and you say, you know what? I don't want it to return a glyph buffer. I mean, a ref slice of U8 anymore. I want it to return an impl iterator item equals ref U8. Okay, so you want to go fully general. I guess you wouldn't do a ref U8 since the U8 is smaller than the ref. And a U8 is copy, so you would never need to build a reference to it. So if you set that as your return type instead, excuse me, wow, this must be the tea. I had 2 sips of tea and then it all started. Then yeah, anything that implements glyph buffer is going to break. You're gonna have to fix that. And then anything else that talks to glyph buffer contents, glyph buffer.contents, is going to also break because it's going to be expecting a different type to come back.
Okay.
So we call that a breaking change, and you have to go through and fix all the code, including the tests that took a dependency on your old public API.
Gotcha.
So you try to make your APIs sufficiently general so that you don't have to do that very often. And while this is fully general, I would suggest that this is also sufficiently general, but even better as a solution, because you're telling your caller that it's a buffer, it's a chunk of data, it's all in one spot. They get some idea of how they can handle it, save it, move it around if they need to. And so that's why this is a very useful type. And we're pretty abstract. We're just saying it's a bunch of bytes. So we're not talking about UTF-8 encoding. We're not talking about any other limitations, or it could be embedded graphics. Who knows what's in there? It's pretty general.
I see.
So you're not likely to need to change that. Like, in other words, what data could you need to represent that can't be represented by a slice of bytes? Right?
Yeah.
Nothing. Right. So like, what could drive a change to this interface? For example, if it was fallible, you could have to wrap it in maybe a result, but you're just asking. But this method is literally saying, just give me whatever I've got in my buffer. So that can't fail. If the buffer's empty, you'll return an empty buffer. If the buffer has data, you'll return, a reference to that data. So it's an infallible function. Doesn't seem likely that this is going to change.
Gotcha.
But if it does, breaking change, no problem. Then it's just work at that point.
Okay.
Okay, so that's what I'd recommend for that particular method, that particular test. So, do I have the latest? Did you change it?
I didn't push any changes.
Oh, okay. So it says no method call content. Oh, so delete glyph is fallible. Does that make sense? We said yes at some point. Let's go take a look. All right. So delete glyph is going to delete to the left, right?
Yeah.
If we get to the end and there's nothing to delete, I cannot honor that. So it is fallible. Whether we want to consider that to be an error or not, or whether that error is called recoverable, is not this guy's business. Okay. So I'm looking at this function, delete glyph, right? And imagine you're in this position in the editor, and then you hit delete, right? Nothing happens because there's nothing to the left of it. Is that an error? The answer is kind of, sort of, maybe, not really, kind of, maybe.
Shouldn't you just like stop them from doing that, like, to begin with?
Well, maybe, sometimes, right? And this is why, this is a part of your first question. When you're designing an interface, how do you know what to do? Delete glyph, delete to the left. It always does something. You're never going to pop up and say error, right? Yeah. No character available to the left of the caret. Like, you're never going to say that. So basically, the delete always works. So why would I suggest that it actually returns a result? The reason is that in the name, this says I'm going to delete a glyph. That is not always true. Okay. It's just thinking objectively. Did I delete a glyph? No, I did not. So that makes my interface a lie. Right? This says, oh, you said you're going to delete a glyph, but you didn't. You couldn't in a particular circumstance. So this function is making a promise. And in the situation that I just showed you, it breaks the promise. Okay? That is the definition of a fallible interface. If it's possible for this function to not do what it says, then you must return whether or not it did what it promised. It is fallible. As a separate consideration, does that failure matter? The answer is probably not. But that's not this guy's job to decide. This guy doesn't want to get involved in policy. It said, I'm going to delete a glyph. Something who calls this can decide when it gets an error back, whether or not that error is material or not, whether to propagate the error, whether to retry, whether to do nothing, whether to swallow the error. It can decide whatever it wants. And it can inject policy at that point. But what's nice is the delete glyph function always does what it says. It either deletes the glyph or gives you back an indicator that it didn't, and why.
Okay, so you'd have like the constraints like in a different function that will like it checks if that's like a legal thing to do.
Right.
Okay.
It checks whether or not the error matters.
Oh, okay, I see.
Okay. So in the case of our editor, whoever is calling delete glyph will say, well, you know what? If I got the no character is available to the left of my current cursor position error, I don't care. So if the caller says it doesn't care, it can receive the error, it can throw away the error, and it can continue business as normal. But it knows exactly what happened, and that's giving full status back to the system.
Okay.
One of the things I would also recommend that we do is to actually return the thing that we deleted.
Like
okay.
Like for logging purposes, or
Maybe.
like for, is that correct?
Caller might be interested. Yeah.
Okay.
Caller might be interested. So whatever we delete, we should send it back.
Oh yeah, like if you do undo or something like that, you need to keep track of it, right?
Exactly. So that would make sense. And remember, refmute itself is really just a richer way of returning unit. So in this case, this function is not going to be fluent, and that's okay.
Okay.
Okay. I only want to be fluent if I'm otherwise going to not be fluent by just returning unit, I might as well return refmute self or ref self. But in this case, I have some data that might be of interest, so that will totally take precedence. I'll go over to the interfaces. Delete glyph is going to return a char. Insert glyph. We can think about whether that could ever fail. No. If you're at the beginning of the file, it doesn't matter. In the middle, at the very end. Yeah, I don't think insert glyph is fallible. Okay, so what I would say about insert glyph is that it's just going to return refmute self, because you know what character you're going to insert. It's the one you sent in. Move right is fallible. Well, that's interesting. I don't care. If I insert glyph, this should never fail. Okay, so if I insert a glyph, let's say I want to put the letter X in here. According to how insert appears to work, at some position. Okay. So if the cursor is at position, let me give an example. I'm going to say A, B, C. Right? Here's our string A, B, C. Or here's our buffer, I should say. And this is 0, 1, 52 in terms of position. Make sense so far?
Yeah.
Let's say the cursor is sitting right there. Okay, so that would be position 1, correct?
Yes.
And we do an insert 1, comma, the character X. What's going to happen is X will go here, but this will still, there's no update to self.position yet. And what we'd like to do is once we've added X, we'd like to update the cursor position to be sitting here.
Yeah, I think that was the purpose of self.move right.
Yes, but we're only on line 52 right now.
Oh, okay.
I see. Yeah, once line 52 runs, that's our state.
Yeah.
And then line 53 makes that our state.
Yeah.
And so because of the situation is that the thing that we've just inserted is now immediately to the right of us, it is not possible for move right to fail in this context. Do you see that? In the context of what we've just done, in other words, in terms of in following line 52, in immediately following an insert, it is not possible for move right to return an error. It is always possible to move right. Why? We just inserted a character that is effectively to the right of us now.
Okay.
Right? So that it can never fail.
Oh, and then the problem is that it returns a result type, right? Which implies it can fail.
Right.
Okay.
Now, move right in general can fail, but we are in a certain circumstance where we know it can't.
Okay.
Okay, so this is exactly the thing where move right should not be worried about policy. Move right should not be checking, oh, am I in a place that can fail? It doesn't know what happened previous to when it was called. It doesn't have the context that line 52 just occurred. All move right knows is it was called to move right, so it does it, and it should do so blindly. Okay. So move right is correct in returning a fallible. It is a fallible interface. And insert glyph is correct in that it should not return a fallible result. So what do we do? Right? Well, the typical and always wrong answer is called unwrap. Right? It's like, well, I don't care. I'll throw it away. No, don't throw it away. Say something to the reader that follows along.
Like .expect or something like that?
Yeah, okay. Yeah, exactly. So in this particular case, I am so sure that this thing can't fail. I should actually say so. Good morning, Mama.
ちょっと人の寝袋しないでよ。はいよ。ママの寝袋はダメ。ダメ、汚れる、破れる、やめて。ママの高いんだから、そんな袋。一生もの。ママ。はいよ。
All right. So this. Good morning, Micah.
寝袋。今。
It's your what?
高い寝袋を汚したり破れたりしないで。今脱ぎなさい。
I can wear it.
つけませんね。あんたはママのじゃない。頼るのじゃない。ママの。やめて。キャンプに行く時だけ。
You put it on me before. It's chaos. The whole family is awake now.
ご飯は朝ごはん食べるの何何よ
All right.
ここの絵に買ってもらったもの使う
Anyway, now we're going to move right, but we know it can't fail. So what do? We have this function. We want to indicate basically to anybody who comes across this code later that this can never fail. We actually think it's impossible to fail. And I think when I write it, you'll see why it's better than an unwrap.
Okay.
So unwrap, and you can see there's a few different flavors of unwrap. And there's a flavor down here that actually takes a closure. And that's the one I like, because I can say, unwrap this thing, but in the event that you can't unwrap it, execute what's in this closure. And I'm going to put the unreachable macro in here, which by definition, if the compiler can get there, it's there. Right? It's not just, oh, I will panic. It's saying like, no, there's actually a bug in your code. That's what this macro is for.
Oh, okay.
So I'm telling future readers of this code, if this can execute, it's a bug.
Okay.
It will also panic. So in other words, the outside behavior, the behavior to the rest of the world will look exactly the same as if I did an explicit panic.
Wait, will panics just completely shut off like the program, or like just end? Okay.
Yep, it will unwrap and put an error, like it'll unwind your call stack and dump out something, and it says, I panicked here after being called here, 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 and here, here, and goodbye.
Okay.
And that's the end of your program. So rather than just calling panic directly, I'm actually telling the future reader of my code that this line, this clause, this closure can never be executed, even in theory.
Okay.
That's a strong statement I'm making.
Yeah.
And it's easy to verify I'm wrong. That's what's nice about making a strong statement. And so then it's easy to verify that I've written a bug. And so in a code review or something, everybody can say, you said this is unreachable, but it's not, and here's how. And I'm like, oh, you're right, I'm wrong. I have a bug. That's the kind of code you want to write. It's either going to be panic-free, or if it panics, or if it threatens to panic like this, it should be easy to prove that this panic can never happen.
Okay.
So here is the code that moves right and tells you if it can't. And here is the code that injects the policy of saying, ignore any errors that might come out of the right, because they can't come. Right? This is really important. Ignore any errors is the unwrap part. But what you haven't, and the reason why unwrap is bad is you're not saying why it's okay to ignore the error.
Yeah, you just toss it out.
Yeah, you just say ignore the error. And I don't know if you're being lazy or if you actually have a reason. You haven't told me. So that's why it's always wrong. It's not evil or something like that, right? It's just wrong because you have told me to do something that is inconsistent with good error handling practices.
I see.
And you haven't told me why that's okay. So expect requires you, I believe, to give a message that would explain why. And that's why for me, that's the minimum bar. Use expect, min bar, great. But if you can go even further than that, if you can actually even tell the compiler what's going on, and if the compiler can do some analysis and tell you that your unreachable code is actually, in fact, reachable, that's even better. Now the compiler has done an a code review for you before you even had to. So I want to say this is unreachable. Okay. So I have now expressed why I think this is expected to take an argument. E. Oh, yes. That's unusual. Okay, so we got an error, and we did not expect to get an error. In this case, what I think move right should do there's only one reason why move right can't move right. And that is
End of line or something like that?
end of line. Yeah.
Okay.
And again, move right's job is not to move down a row and over to the left and all of that. That's policy. That's somebody else that's going to do that. So if there's only one reason it can fail, then we don't need a result where you can specify all the different reasons it could fail. What we could do instead
Option. Okay.
is put an option, because there's only one reason it can fail. So you either get a result saying that it was successful, or you don't. Shorter. I didn't close it. Yes, I know it doesn't match the trait yet, but it will. Okay, and set position, I don't know. That might be able to fail for many reasons. I don't know yet. Okay, so that part makes sense to me. What will happen here is I'm not going to receive any sort of error, because it will be none. And that should make it happier. Move right. And so it still thinks move right is an option. Yes, that's right. Correct. Okay, so that's good. So now I just have to go back and change my trait. So if I delete a glyph, you're either going to get the character or you won't. Insert a glyph always succeeds. Move down will only fail for one reason. Okay, so do you see how the interface is evolving as we are thinking through more specific cases, and we are able to, maximally constrain the data types. I don't want to be loosey-goosey and let it return anything at once. I actually want it to be really constrained, so that way what comes out is highly regulated. Think of it like, some sort of essential services to society kind of business. Like, it'll be highly regulated, right?
Yeah,
That's what you want. That's a sign of a good interface, is that you're getting exactly the expressiveness you need, no more, no less.
Okay. Guideline number 1.
Yep, exactly. Okay, so now it's happy. We are basically unwrapping, but we're telling you why it's safe to unwrap. And okay. I think that's pretty descriptive. I'm telling you right here in plain English what my assumption is. that justifies throwing away the error condition and why I consider that to still be safe. And the compiler gets a swing at it because if it can see a code path through to a code that touches unreachable, it means that that's a bug, so it will stop compiling. If panic was written there, the compiler would say, oh, he just wants to panic when I get there. That's perfectly fine. I will do that. I'm saying I do not want to panic when I get there, although you will when you get there. What I want is to tell you that you will never get here. Stop compiling if you can find a way to get here. That's a very strong statement I'm making to the compiler. And so this code will never run because it shouldn't ever compile. An unreachable that's in your code path will never compile, as far as I know.
I see.
And so if I'm right, then the compiler will be like, okay, I can't get there. Good. Okay, so now we've moved right unconditionally. So now the cursor is here where we want it. We know that that can't fail because insert is infallible, and this is assumed to be infallible. So therefore, simply returning ref mute self is sufficient. And that gets us insert glyph.
The sum keyword is the it's like okay from result, right?
Yes.
Because option returns sum and then was it like none? Was it?
Yeah.
Okay.
Mm-hmm. You can see it's an enum. You get a none with no payload, or you get sum with a T.
Okay.
And it's option T. So that's where your T goes.
I see.
And result is the equivalent, except there's an E, and the none gets the E, right? And the sum, or in this case, the error would get the E, and the OK would get the T. So they're cousins for sure, or brother and sister, or whatever you want to refer to them as. Yeah. Okay, so that looks pretty good to me. So now I'm going to go back to the unit test and see, how much stuff I broke. Insert glyphs is infallible, so that goes away. I no longer need to then run the try operator, so that goes away, which means that this can go away. Contents comes back with interesting. So I have to use glyph buffer. I am assuming that's going to be important for all my glyphs. So I'm going to put that up a level in unit tests. And actually, I'm assuming that's in buffer already. Interfaces, glyph buffer. It's right there. What's the problem? This guy's using super, which is here. That's right, because insert glyphs is here, which is using super, which is taking me to here, which is being included. And this has glyph buffer. Confusion. Let's see if it's a real error or if it's just my IDE. Okay, so I've got some issues there.
So the problem is the test doesn't know you're implementing the glyph buffer trait.
Right. It's saying you've got a type. What it's saying is you have a type, which is whatever was returned from insert glyphs, which is what? Insert glyphs in buffer is fallible? Oh, glyphs plural. Each of these is infallible. So doing it many times is also infallible. So insert glyphs cannot be fallible. All right, so now all you want is a semicolon. Interesting. I don't need to map that now to a null. But insert glyph is going to return ref itself, so I'll need the semicolon. And then that's where this goes, and then this goes away, and then this goes away. Okay. Happiness. Okay, so all I did is to say, hey, if insert glyphs just calls insert glyph a whole bunch of times, and insert glyph is infallible, then insert glyphs is infallible. So I took off the result here.
Okay.
And then I go back, and then this guy's happy.
Okay.
So all it's telling me is all the types make sense now.
Gotcha.
That should have made sense. All right, so I go here to no method in contents. All right, so I mean delete glyph. Delete glyph is using super, so therefore, okay, so delete glyph is returning an option. Char. Ha ha ha. See, this is great.
What happened?
Okay, so what I did is I said, look, we're either going to get the character we returned or we're going to get nothing. And I'm even thinking, or we're going to get nothing. So in this case, we have an empty buffer, and then we call delete glyph on it. So delete glyph is going to return none here.
Oh, okay.
Here I am trying to, unwrap it and get the contents, quote unquote, of the buffer. Really, what's going on is this test should be, the result I get back is not refmute self anymore. The result I get back is actually the character that got deleted, which in this case should be none. So I can assert that result expected char. Optional char is none. I should assert. Well, are we using assert too? No, we're not. Okay, yes, that's right.
Oh yeah, so what's the difference between like assert exclamation point and then like assert EQ?
Assert exclamation mark. I would express the above result equals expected this way.
Oh, okay.
And the reason that they made assert equals is because it's easier for the authors of the language to say, here's the left side and here's the right side. They didn't have to parse the expression.
I see. Okay, that makes sense.
I think that's nuts that you would pollute an entire ecosystem because you were too lazy to do what's called expression trees. So there's a crate called assert2, which lets me use the syntax that the language already defines for equality, and will still do this, give me the same output as assert eq. So that's what I use, is assert2. But I didn't want to get you used to writing assert because it's idiomatic in the Rust ecosystem to write assert eq and doing it this way.
Okay.
But I don't do it that way because I think it's bad to implement a domain-specific language to cover something that's already there, especially given that it's incomplete. What if you wanted to say that?
Oh,
there is no such thing. They didn't even bother making it.
Okay.
Right? So it's like, I get this duplicate behavior for equals. I get an incomplete implementation for greater than, less than, greater than, equal to, less than or equal. It's a mess. It was the wrong thing to do, in my humble opinion. But when I'm teaching, I think it's important to just be idiomatic until we get the hang of the language, and then we can start sort of opting out of things as appropriate.
It's not work. You guys just don't use EQ. You guys use the other or your way.
Well, yeah, most of my team is not are not Rust experts. They're coming from other languages, so they're learning, and I'd say half the team is still coming up to speed on sort of the finer points of Rust.
Okay.
I mean, they're all proficient, but they're not. That's Rust 2018 syntax. Oh, that's Rust 2015 syntax. They're not like nerds about it yet. And the other half is, so.
I like how you said that.
Yeah, I'm working on them. And the buffer should still be empty. Right? It should be the same as an empty buffer. I'll say so. Okay, and so by telling the code what I'm expecting, I think it's pretty descriptive that I don't expect the buffer to change. I expect to actually get a none to come back out of the delete glyph, and that's all working. And then in here, I'll do the same thing. So I'm going to get my expected buffer here. I think the state of the buffer, I'm not going to put the state of the buffer in the name. I'm just going to let the state of the buffer be reflected by its value. And then I will make a new buffer. I will insert the glyph. I will not fail. I will not be in a fallible function. I will not return a result. And then when I delete the glyph, I will have the same tests or the same results.
So when you assert twice, that's not like, oh, like that's not like two tests, right? That's like, oh, in order for this test to pass, then these two asserts have to be true.
That's right.
Okay.
So what would happen if we called delete, we got the expected character back, but the buffer still had the character in it?
Can you repeat that?
What would happen if we called delete and delete gave us back the character that we deleted? Delete glyph. There we go. Oh, it's not implemented yet. All right. So what would happen if we called delete? This is not the function I'm looking for. There we go. So what if we call delete glyph? And as expected, it gave us back the letter A. Because that's where we were, and that's what was in the buffer. And then if we check the buffer, it contained also that same letter A.
Oh, then that's something that we don't want, or that's something that should fail.
Well, when you say delete, do you want it left in the buffer? Is that your intent? When you say delete this file, do you want it left on the file system?
No.
No, like if you hit delete on the file and the file shows up in the trash can, but also stayed on your file system, and then you empty your trash, you think it's gone, but it's still there. You're like, damn it, I can't get rid of this file. Right? That would be a bad state.
Yeah.
So in our then clauses, we should check all the state we need in order to ensure that delete glyph did its job. Delete glyph should have mutated the state of the buffer and removed the thing that was actually handed to us.
Okay.
So we have to get the thing we're expecting, and we have to see that it's gone from the buffer.
I see.
Right? And so if you need to apply asserts in order to prove that your state was the way you expect it to be, then that's what you would write there.
Gotcha.
Okay, and so we're going through and we're going to do the same thing here. So you can see we have a lot of tests to fix because we just broke the public API. Okay, so here we have what we expect to have left in the buffer. And so we're going to delete something and then end up with the right resulting string. So we set everything, we set data. Okay, I guess we haven't written that yet. And then we're going to delete glyph, and delete glyph will give us back an option. And then we're going to check expected.
Yeah, I think I'm
So
trying
here,
to understand like my line of thinking from like this past week, where I was like trying really hard to not break the test, but I think I was thinking about that like wrong. Like I'm not necessarily breaking the test. It's like I'm breaking the test so I can expand it, right, to make it more accurate to like what I'm trying to do.
Yep, another name for what we're doing, and you can search this one up, it's called red green refactor.
Interesting.
Okay, and so like the TDD methodology is also known as red-green refactor. And so one of the things we're doing is we write a test first and we run it and it's red because there's no implementation to support it. Then we write the implementation, it's green, that's great. And many times we'll end up having to refactor our code because we discovered something new or we need to change our interface. And so fine, then refactor.
I see.
And if that breaks this code, the amount of breakage will be very high at the beginning, but that's okay. We only have 5 tests, right? And then as we get further along and we think getting things are really stable, we got 500 tests, we won't be breaking because we're like, no, we've exercised this in 499 different ways. And we haven't found we've definitely got the right interfaces on our methods. And so then it becomes very rare to have sort of a breaking public API.
I see. Yeah, like right now, like I did a cargo test from from last week. I'm like, oh my god, everything fucking broke.
Yeah, exactly.
Now learning it's expected. Okay.
Right. When the interfaces are mature and you make a change, you should not break a lot of tests. In fact, it's a symptom of you're doing it wrong. If making a change in your code breaks a lot of tests, it should actually break 1 test exactly. But that's not the case for breaking your public API, right? A public API is a breaking change. So it's like, okay, that's, it's a big. So particularly if you do it via a trait, you're going to break in a lot of places. But like I said, your public API will be probably the first thing in your code to stabilize. So this will not be a problem for very long.
Okay. Oh yeah, I forgot to tell you, I'm actually recording this session. Is that cool?
Yeah, no problem. No problem. Weird. It doesn't say.
Oh, I'm doing it through like my laptop right now. I'm not using like the
Oh, you're just using like a screen recorder.
Yeah.
Yeah. Okay. Yeah. Well, thanks for letting me know, but no problem at all. No problem at all. When you post it to YouTube, my wife yelling at the kids to not use a sleeping bag is going to be on the.
They're using a sleeping bag.
Yeah, my son. It was cold here, or we're in this rental house, so my son grabbed her sleeping bag, and I guess she didn't want him to use it or something, so she was like, "Don't use my sleeping bag."
Oh, okay.
And he's rolled up under my desk right now, playing Roblox.
Wait, under your desk?
Yeah, he lay on the carpet.
Let's
show you here. Where's this? Can't even find this thing. Man, Zoom is not my friend.
Yeah, I'm honestly surprised it has such a large market share, to be honest. I don't think it's that impressive. Oh, okay. Hello.
He's got headphones on, so he can't hear.
I can't hear.
Oh.
I can hear it like quite clearly.
Yeah, so he's playing Roblox. See, I got my winter hat and my robe on because it's cold here, man.
It's cold here as well.
Yeah, we should turn up the heat. So, all right. Okay, so we got a bad sentence, an expected result. I'm not sure I like the string yet, but I don't know what I'm going to put there yet. I'll get there in a minute. But I do know that I'm going to delete the B, so I'm expecting an E out of this thing. This is position 0, 1, 2, 3, 4, 5, 6. Itterashai mama. So that's 6, so that's correct. Let glyph pause equals 6. Magic numbers just sitting there for no reason other than 0 and possibly 1 I frown upon. So I just give it a name. just to make it obvious that, oh, position 6 is the position, and positions are often 0 indexed. And so folks should be able to figure out that I'm talking about this guy right there, rather than just saying 6. And we set the data to bad sentence. We don't have a set data yet. Do we not have a set data yet? We don't have a set data yet. We do not. Okay, fine. So that should work. And then when we delete the glyph, we should get back all right, so we should get back the expected glyph. And then how do I construct a buffer in this state? Without using privates. That's what I want to know. New. Insert glyphs. So it's going to take an iterator of glyphs. Okay, I can do that. Okay, here's the interface I want. Okay, here's where that interesting tension is here. Insert glyphs. Delete glyphs, insert glyphs. So when I insert glyphs, I have to do sentence.chars. The interface that I want is I would like to be able to put in sentence.
Chars turns it into an iterator, right?
Yes.
So you're gonna, the actual iterator is gonna be in the implementation, or like the actual
Correct.
act of going,
Yep.
parsing. Okay.
That's right. So it's just easier to use, right? I want to make an ergonomic API for my users. And it's obvious that a string can be broken down into an iterator of glyphs. And so I should just be able to hand in the string. In fact, glyphs are copy. So I should be able to hand in a ref of that. And it should just do what it's got to do. That's what I'd like to hand in, is a ref of a collection, have that collection turned into a borrowed iterator, and then iterate through everything. Each char is copy, so the buffer gets its own copy of everything, no matter what. And then the caller is left with their original sentence if they want it, or they can just stop using it. So that's the nicest API I can think of to use. It's very easy. I don't have to worry about clone and keeping my own copy and all that good stuff. So, okay, so how do I do that? I don't actually know off the top of my head. So insert glyphs has to make this happy. So if I go to insert glyphs definition, I'd like it to be a ref to something, because I sent a ref of sentence.
Yeah.
That's good. Now, what's the something? The something is going to be into iterator? I do not know. Let me just quickly check. Into it Rust. Rust has something called an into iterator. I don't know if it's a trait or not. Or if it's a struct. It is a trait.
Oh, you stopped screen sharing? Oh, okay.
I made it my desktop so you can follow me as I jump to different places.
Oh, I see.
So there's this trait. I was going to write something to the effect of into iterator item equals char, something like that. 1, 2, yeah. But I didn't know if that was right or not. So it looks like there is a trait called into iterator. Does everybody who implements iterator also implement into iterator? I would imagine not. I'm not sure. I use into iterator. Into iterator versus into import. That's never going to resolve. Says. Okay, so here's my problem. If I say I can take any type that implements into iterator, then all the types I get, like string and so on, that are in the standard library will work fine. But I know I have made several different types that implement iterator that don't implement into iterator. And all I need is an iterator. So the base requirement is not that into iterator is implemented. It's that I could turn the darn thing into an iterator.
I don't think
super confusing, right?
Yeah. Wait, yeah. Let me say it so I like maybe you could see like if I understand or not. But you don't care if it's typed into iterator. You want the act of converting it into an iterator.
Right.
Okay.
There's an iterator trait, and there's an into iterator trait, and then there's an into trait. So there's 3 traits involved. So I'm taking a string and I'm converting it into an iterator. So it would seem that I want this ready-made into iterator trait and say, hey, if you hand me anything that's an into iterator, I will just work. And that will work for sure. But it's too narrow. It is possible, unless there's a blanket implementation on into iterator. Ooh, let me just check one thing. Into iterator. Oh, never mind.
That's the answer.
Here it is. Okay, Rust does this thing called blanket impl, blanket implementation. So like I said, like I make some struct foo, and I implement iterator on foo. So foo can now has an iterator. But what if into iterator? What if I don't bother implementing into iterator on foo? It turns out I don't bother because Rust does it for me. Rust implements into iterator for every type I, where I implements iterator.
Oh, so in our scenario, we have a string, but it's not an iterator yet.
Right, but string Oh yeah, string doesn't implement iterator. Chars implements iterator. But string has. Let me just look it up. That's a really good question.
Yeah, because I remember we sort of bumped into this problem before, which is why we had dot chars there, like in the first place.
Yeah. 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 Okay, so this one will have the chars somewhere. Struct string. Great. It's not even on string. It's on slice. Okay, so I'm going to get a struct back called chars. This chars implements iterator. So therefore, it will also implement into iterator. So it's already there. That's not what I want. Does Freeway have breakfast, Tayo? Tayo?
Huh?
Does Freeway have breakfast?
He didn't eat his dinner last night.
So he has fresh water, full water, and food?
I didn't eat it this morning, but last night he checked before he went to bed and he was still eating it.
Okay, well, I'm not asking for you to check last night. He might have eaten it all overnight. I don't know. Please check in the morning. Thank you. Okay. So this is everything I want is on chars and it's on every iterator. So yeah, you're exactly right. There's nothing on string that's going to tell me this thing is convertible. Methods from dref. Okay. Traits. What you got for me? From iterator. What? It implements from iterator for string. Okay, so I can build a string out of an iterator. I can build a string out of iterator of chars. I can build a string out of an iterator of strings. All of that makes sense. But there's no iteration ability. Okay. Okay, so this convenient user interface I want can't really get there from here unless there's one last thing I could try. It's pretty interesting.
Magical things I've ever seen in my life.
What?
It has that perfect star shape. Isn't it neat? Doesn't it look so cool?
Yeah.
Oh, I think the seeds are there.
Yeah, could be.
They feel something.
Char indices, bytes. Yeah, there's all kinds of iterators, but none of them are. Not yet, thank you.
Yeah.
Yep, there's all kinds of iterators, and that's not how Rust wants to work. So, too bad for me. to insert glyphs. And so I'm not going to get my wish.
So you just have to do dot chars.
Yeah. There's other more sophisticated ways I could make it happen, but no.
I respect it.
Well, I mean, here's the thing I'm thinking. Rust vector can be turned into like when I'm thinking of a collection, like a vector. Vector has the iter method and the iter mute method, which are the equivalent of char. But I actually think it has, see how it has the into iterator trait implemented on it?
Yep.
But string, even though it is a collection of characters, is sort of thought of as a high-level data structure, not as a collection. And so if you want to think of it as a collection, you say something explicitly. But I can't just hook into the string using the into iterator trait. So what's interesting is that I could still improve this implementation. I think that's the right answer, even though it doesn't change for string. And then for string, I could do something called an extension trait that would actually make it work, but it's not necessary. It's called into iterate. Let me just look at the code for it, into iter. And it has a all I need is type. Oh. So it's some iter later. So chars is an iterator, you know, iter is an iterator, into iter returns an iterator. So there's all these different types of iterator and they're not unified. I actually don't care. It's like any kind of iterator is all I care about. So this feature I think is just not ready for prime time. I think the way I'm doing it is pretty much the best I've got, that or the best Rust has that's simple. And so I'll also stick with that for now. So let's see what else we've got. Cannot find value expected buffer in this scope. Expected result. And then it's going to tell me dot as bytes. I'll say give me the contents of the buffer. And those should be comparable. I don't need. You see how my function signatures clean up nicely? Yeah. So making these things sort of tightly scoped means I'm not introducing any new noise, but I'm accurately describing everything that could happen in terms of these signatures. Okay, so this guy here, I could return this value, so I will. If it's an error, this guy set.
I don't think this exists anymore with the way we changed it.
Right. I didn't delete set yet. So maybe, or at least not today. Maybe it was last week we did that. Where is this guy? Position. It's the set, which is the buffer, which is the position, which is a position, which is call row coords. Oh, because we made it immutable. Remember? Yes, 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 yes. So I create a new position and just tell it what I want.
Yeah.
Set dot.
Oh yeah. So last week we were also getting into like how whether it was like better to mutate something. Or, well, in this scenario we're making it immutable, so like we just create a new one, right? And this was like a one-off thing where it was like, or I guess it was or you made it seem like it was somewhat controversial, where it's like, yeah, it's just better to create a new one instead of like mutating an existing one. I don't know if you want to get back into that, because I felt like it was more of like a opinionated thing.
Well, it's objectively true that it is easier to write correct systems when they are immutable. Okay, there's no debate about that. Anybody who says otherwise does not know what they're talking about. It's just true, right? If I never write, I can run many threads. Simple example, right? Just one example proves it. If I never write to my data, I have a spreadsheet full of data, and I spin it off into 100 different threads, and they're all reading different cells at different times. They will never interfere with each other because nobody's writing, right? It's much simpler if data is immutable, that you can make it multi-threaded. You don't need mutexes, you don't need locks, you don't need synchronization primitives. Your code is just simpler and it's correct. Just don't make anything mutable. Unfortunately, the real world's messier than that, and sometimes we need data that is mutable. So there's techniques to either mutate data or simulate mutating data. And so the debate is there. It's like, should I allow should I allow this line 45, or should I require line 46? Okay, line 45 means the data can be mutated directly, which means every cell in the spreadsheet now has to carry a lock. And you have to lock it, then you can access it, then you have to unlock it. Don't take too long. Don't crash while you're holding the lock, because then you poison the mutex, and there's all this complexity. Because if you crash while you're holding the lock, it never gets returned to the system. And that cell is now dead forever. All kinds of issues, very complex. If we do number 46, there's a little bit more verbosity. You see that, where I have to create a new position?
Yeah.
I can cut that down and make that really, really minimal. But there's a little bit more verbosity. And so people don't like that.
Okay.
There's a little bit more, there's more objects being created by the system on the stack or in the garbage collector. People don't like that. So compared to the complexity of the other solution, line 45, it's a bargain, right? We should definitely take this as the option, but not everybody agrees with that. So that's really all there is. But this is much safer and much more scalable, because we are writing to the buffer, right? In terms of where its set pause field is set to, but we have to write to the buffer anyway in statements like this. That's what it's for. So I'm not actually adding complexity to the system. The buffer already has to be protected by its very nature of being a mutable data structure. So the fact that I'm mutating an extra field on the buffer doesn't matter. Buffer was already subject to all those restrictions before.
Okay.
So anyway, I think that's a modern way to do it. We'll pass in the new position. We don't have a set data. Do we want a set data, or do we want a insert glyphs bad sends dot chars? Okay. So we can have a set data that makes this statement, as a convenience thing. But I think once we get used to it, it should be okay. Okay, we're down to 10. Set data. Insert glyph, sends.chars. Contents is expected result dot bytes. Do we have anybody failing? No, we do not. Down to 8. Insert glyph does not fail. It's going to return ref mute self. I just let the compiler guide me. Okay, so you are testing buffer.set is what you're testing here, and there's no such thing. So what you're really wanting to test is buffer set position.
Oh yeah, we that used to be update, and then we changed it to set, and then last week we changed it to set position.
Okay.
Yeah.
Set pause. Okay, there we go. So we're going to do set pause, update position to invalid coordinates fails. So to do that, I'm going to have a new buffer. Because the buffer is the subject under test, not the position field.
Yeah.
So this is the set. The invalid position will be set to 6. The expected result is this. Invalid position. 6. Then invalid. Invalid. 0. Expected result. I don't think it's a position. It's an error. Move the set down. set pause. Position. All right, and then I should get an error. So set position to an invalid position is going to give me some error. And that error is failed to insert. So we don't even have the error defined. All right, so let's define the error. Invalid position specify. That sound good? Invalid position?
Yeah. One thing I'm definitely not used to is making custom error types. It's usually like I usually just like, oh, this compiled wrong. I guess that's my error.
Yeah, well, yeah, this is something where I'm definitely showing you sort of how to build enterprise style software.
Yeah.
It's going to be very big and live for a long time. It takes many, many, many minutes to compile. So each part has to be self-explanatory. Otherwise, things get really ugly. What's wrong with that? Oh, I failed to okay, so I have a new error called invalid position. So that's the one I'm going to expect back from the test. And then the position is going to be the invalid pause. And then I should be able to say that you are as dref is probably going to mean ref. Pain in the butt. Arch. Arg. Can't move. As dref dot why am I getting this as dref? Set pause is going to return a ref mute self an error. Okay, so I'm just going to say, give me error. Dot expect error. There we go. And then this should be expected enum error. Oh, huh? Well, I should just be able to compare them. Yeah, okay, that was easier. Okay, because I'm actually expecting to get an error back with this value in it. And now this should compile. Will it even private field? New. Okay. Okay. That's okay. That's all fine. Okay. So now everything that's running is because we did not finish implementing some of the things that we've used. Okay, this one's pretty easy.
Yeah. Yeah, I think I could do this myself. Oh, I mean, because I still want to get into like general like rules for like a good interface.
Okay, so this would be a good spot then to do the check-in, and then we can talk about interface design. Is that what you're thinking?
Yeah, yeah.
Refactored tests to okay. All right, so that now gives you a good base to start working from. You will be able to see how your tests build, and basically the only errors you're going to run into are the unimplemented errors, which are right here.
Yeah.
Right? Okay. So in terms of building an interface, there are countless guidelines, and there's no one right way to do it. But what I can do is share sort of my experience, and I don't get boxed in. I tend to build interfaces that scale quite nicely and don't get, what you don't want is your interface's complexity to be proportional to the size of your project. Okay, project gets bigger, interface gets more complex. Okay. That is not what you want.
So keep it simple, right?
Keep it simple, right? Okay. But it's hard because if you have to sort of handle all scenarios, you sort of, as the scope of your project grows, the scope of your interfaces grow.
Yeah.
Well, the best single way I know of to fight that is a single responsibility principle. Okay, so what we did earlier today was a big deal when we said, you know what, or move right. Move right in the only circumstance we have never fails. Right? When we call move right after we do an insert glyph, it never fails. So it would be quite reasonable to write a move right or to write a infallible move right function that never fails. But we have just broken that premise I just said. You don't want your interface to get more complex as your app gets more complex. What happens when move right is called from a context where it can fail? It's at the end of a line. The user is moving a cursor. Oh, well, that's a different move right. Okay, so boom, let's make a fallible move right to go with the infallible one. Now there's two ways to move right. And the user has to understand why you did this. And times 10,000 interface calls, it's overwhelming and complex. So if I say, look, if you call me, I'm either going to do I'm going to do exactly what's on the label, or I'm going to fail and tell you why.
Okay.
Every function you ever write should be able to adhere to that standard. I'm going to do what's on the label, or I'm going to tell you why I couldn't. Right? If you're going to do what's on the label and it cannot fail, that is an infallible function. You do not need to return an option or a result.
I see.
If you are writing a function that will either do what's on the label, or maybe through circumstances beyond your control, it might not be able to do what's on the label, then you must use an option or a result.
Okay.
If you design your interfaces that way, your interfaces will scale very well. If you make sure that you keep the policy out of your functions, you just do the thing you say on the label and nothing more, certainly nothing less, but certainly nothing more, that's where we always fall down as an engineering discipline. It's like move right actually moves right. It actually checks to see if it's safe to move right. It does the wrap to the next line if necessary. And it's like, whoa, 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 that's not moving right. That's moving right and.
Yeah.
The problem with that is the single responsibility principle. I don't have a single responsibility anymore. I have 3 responsibilities, right? To check to see if it's okay to move right. I have a responsibility to move right, and I have the responsibility to wrap to the next line.
So you would implement the check as like a separate function, right? Or
Yeah.
Okay.
The check would be a completely separate function, and then the wrap would actually encapsulate both the check and the fallible move right. Right? And so the wrap would say, am I here? And then it would say, oh, I am. So the wrap is where the policy is because it's wrapping. It says on the label, right?
Oh, wait,
so
what's wrapping in this context?
Wrapping is going from the right margin to the left margin, the last character of the right margin. The last character of row X to the first character position of row X plus 1.
Okay.
Okay, so you just move that cursor from the right side of the screen down a line and over to the left side of the screen.
Gotcha.
So if you created a wrap function that actually called the check, that set the pause, right, to move the character right or left or whatever, then the wrap function does only what it says. It's gonna wrap. And if you're in the middle of a line and you say wrap, what does that mean? Right? If you're on character 40 and there's like 40 characters to the right of you and you call a wrap function, do you still want it to go down to the next line, or is that an invalid call? Right? You get to make that decision. But if somebody did like a shift enter or a control enter and you just want the cursor to go to the next line, you could say, look, unconditionally, I don't care where I am on row X. I'm going to go to row X plus 1, position 0.
Okay.
Okay, you could decide that. Now, on the other hand, you could say, no, I do want to check to see that I'm at the right margin. Otherwise, I'm going to just ignore this call. At which point your wrap would need to return an option because it might not do what's on the label.
I see.
Right? And so that's how you know how to design your interfaces. They only do one thing. They have to do exactly what's on the label, no more. That's the real trick. You will tend to write code that does more than what's on the label. And you have to determine whether or not it's fallible. If you get those principles right, I think you're off to a really good start.
Okay. So single responsibility. That's the key.
That's one of the keys.
Damn, multiple keys.
Yeah, no, I mean we just covered a bunch, right?
Yeah.
So that's definitely one of them. Okay. All right. So, do you have any other questions for today? Because I think it's a pretty good stopping point right here.
Yeah. You pretty much answered everything.
Okay. All right. Well, take a swing at this, and we'll get together next Wednesday, and we'll see what new exciting adventures have come up in the meantime.
Yeah, sounds good.
Awesome, dude. Well, thanks. Talk to you soon.
All right. Yeah. Have a good day.
Okay. Bye-bye.